I'll hand over the time to you.
Okay. All right. Well, thank you, Dr. Meng, and welcome everyone to day 2 of this MIT App Inventor crash course. Today, basically, we're going to continue building upon what we learned yesterday, review a few topics, and then we're also going to start building on some of our own projects. And I'll walk you through how to build some basic projects using concepts like control flow, as well as new topics like data structures, like lists and dictionaries, a lot of interesting things like that. Just throughout the lecture, also I'll say, if you want to ask questions, you can put them into the chat, or you can just unmute yourself, because while I'm sharing my screen, it might be hard for me to monitor the chat. Dr. Meng, do we have a TA for today's class?
Yeah, Ambrose. Okay, I'll be here. I'll contact TA, because otherwise I'll be here.
Okay, yeah. So
as his replacement.
You can just, because you can just message Dr. Meng directly if you have any questions, or you can just put it publicly. So, yeah. All right. Yeah, so I'll go ahead and share my slides for today. All right, so we're going to first start off by learning about loops, which is a super useful, I guess, concept in programming, especially in MIT App Inventor. And before we get that done, we're going to do a little bit of recap. So yesterday we got pretty much exposed to the basics of MIT App Inventor, how the interface looks like, as well as some of the basic programming languages that are programming concepts that are the backbone of MIT App Inventor. So we learned about what are called data types, and data types are essentially ways of differentiating data. And each type has different roles and rules, and every variable has to be assigned to a data type. And so you can think of these as categories that the different types of variables can fall under. And the major 3 in MIT App Inventor are called math or numeric data type, Boolean, as well as string or text data type. And so for math or numeric data types, these are number values, and they're used for math calculations and counting. Next is Boolean data types, which are true or false values. It's a binary data type. It can either be true or false. And we talked about some of their uses in logic, as well as comparisons and control flow in MIT App Inventor. Then there's also string data types, which is like a sequence of characters. And these are used to process and display different words or text. And then next to each of these, you can see an image and then the different examples of these data types. And in MIT App Inventor, they're also color coded. So math or numeric data types are blue, Booleans are green, and then strings are this. It's pink, purplish color. Yeah. So one thing that we also talked about was the idea of adding randomness to your code. And there's a lot of different applications for randomness. For example, I know one app that I saw on MIT App Inventor was for people who wanted to pick oftentimes we struggle, if you want to get food from a restaurant, we struggle to think of what restaurant we want to go to. So this was a really simple app that just generated a random number and a random restaurant for you to do if you couldn't pick. And that's a pretty direct application of randomness. And randomness falls under kind of the numeric data type in MIT App Inventor. And it's pretty self-explanatory. It's used to generate random numbers. Now, one of these blocks right here is a random integer, which is a random whole number from a lower bound to upper bound. So this right here would generate a random number from 1 to 100. MIT App Inventor also has a really neat application where you can generate a random fraction, which is between 0 and 1. It would just generate a random decimal number between those two ranges. Then MIT App Inventor will also generate you can also combine these two ideas of generating an integer as well as generating a fraction to generate a random number with a decimal, like you see here. And so with that, you're basically able to generate any number you need. And you can use that in many different ways in your code, like we'll see later on today in one of our walkthrough projects. Next, let's go into some of the specifics of text. So Text, again, is like a sequence of characters. That's essentially when you think of any string, any sentence, any paragraph, all that is, if you really think about it, is just a string of letters or a string of characters. And these can be really any length, and special characters and numbers are included. And I'll also add like spaces or white space are also included as well. Like for example, the space within grocery store is also included as a character within that. So make sure when you're trying to count the number of characters in your text, you also have to include that white space in, or that those spaces in between. So that's something you have to keep in mind. And because because text is like a sequence of characters, one thing you also have to remember is that these are a numbered sequence of characters. So every character in that string or every character in that string of text has an index. And so a great example that we talked about yesterday was like with this grocery store. And so with grocery store, we literally can start counting off the characters, and that can give us a sense of where different characters lie in that text. So for example, here, grocery store, we start off with the first character, which is 1, and then we can just count G is index 1, R is index 2, O is index 3, and on and on and on until we get to the final index, which is index 13, which is the letter or character E. One, like if you've done other coding languages before, you may be used to it starting off with 0. Almost all coding languages start off with 0. But for MIT App Inventor, to make it easy and to help get kind of beginner programmers more exposed to programming concepts and help them wrap their minds around this, it starts off with the index 1. So that's just something that you can keep in mind. And we saw different applications of why this is useful later on. So there's different functions that we could do with text. Some of these include joining text, which is like combining different text together. Remember that there is no delimiter when you do this. So when you combine these two texts, MIT App Inventor is not going to add a space in between automatically for you. It's just going to combine them as is. That's why you see here, there's no space between the word hot and dogs. It just combines them two directly. Numbers can also be combined, but it's different from the plus operation in mathematics. So it's not like when we say we want to join the numbers 9 and 5 right here, it's not going to join, or no, this is not a join function, sorry. If we said like we wanted to join the numbers 9 and 5, it's not going to give us the number 14. It's going to give us the number 95, or string 95 rather. So that's something you have to keep in mind if you want to join numbers together. If you want to join or concatenate them, you can use the join string built-in string function. But if you want to add them, you use the math plus function. Also, the indexes that we talked about earlier, the indices, can also be used for splitting text. So if you want to cut from a certain index to a certain starting index to a certain ending index, we can do this with the segment command in the inbuilt it's an inbuilt function in MIT App Inventor. So for example, with the word grocery store, if you wanted to start with the index 9 and then take a length of 5, if you look right here in the word grocery store, the starting index is 9, then we count 1, 2, 3, 4, 5, and then we're able to get that store is the segment, or the segment that we want that fits our criteria is the string or substring store. And now what I'll do is I'll give you guys an example like problem that you could do. So just type into the chat, what would happen if for this function right here, if instead of starting with the index 9, I said I wanted to start with the index 8 and I wanted to spit back a length of 4. So replace the same from the text grocery store, I start with 8 and then I ask for an index 4. Just put in the chat what would result from that. So already getting some answers. I'll give you guys like maybe like a few more seconds. Russell put an answer into the chat. Do you guys agree with this answer? All right, so yeah, so all of you guys seem to agree, and that is correct, right? Because we start off with the letter 8 or index 8, and then we want a length of 4. So we go 1, 2, 3, 4. So we do have to include that white space. A common mistake that people might make is just assume that white space kind of doesn't matter. and then they just might do STO, but you guys caught that. It also includes the white space. So that's good. So you guys seem to kind of get the hang of that or understand that segment command. And again, this is called a substring in other programming languages. I may have just like called it substring myself just because I'm used to using the word substring for other languages. But in MIT App Inventor, it's called segment. All right, let's keep going. So there's also the idea of searching for text, right? And so searching for text is also really useful. And MIT App Inventor, it kind of abstracts a lot of the nitty-gritty stuff behind this, just with this contains function. And we're actually going to be using this in one of our walkthrough projects today. But contains is basically like finding if the substring or the smaller piece of text is within this larger piece of text. So for example, in this sentence, Kevin is watching TV shows, the word is, you can clearly see that right here in the text itself. And so it returns back a Boolean of true or false. So if I ask for, is the word banana in, it's the piece banana in this longer text, it would return false because banana is not in there. It doesn't necessarily do partial matches or anything like that. That string has to be perfectly in there, exactly how it is in the piece. So if there was a I space S, that would, like if I'll type it in the chat. Like if I, instead of is like this, if I asked for I space S, it would return false, right? Because it has to be exactly how it is. That it doesn't like reduce the white space, it counts the white space as well when it's searching within that larger piece of text. So keep that in mind when you're doing the contains function. There's also like this starts at function inbuilt in MIT App Inventor, which is super useful because it checks if the text contains a piece of text, just like this contains function. But instead of returning back a Boolean, it returns the index of the first appearance of this piece of text. And it returns a 0 if the piece isn't present. So in this case, is would return the index 7. And just like before, I'll give you guys an example problem. What if I asked for starts at, instead of asking for the word is, I asked for the word TV? What would it return? So I would do starts at text, the same sentence right here. Okay. Russell asks a pretty interesting question. If you put is in the piece like in this function, and you write the word this in the sentence, is it going to return true? The answer is yes, it would return true because an exact match is found, right? Of that substring. It doesn't matter if it's like something is next to it or beside it, as long as an exact match is found, then it would return it. But if I ask for I space S, an exact match isn't found, so it would return false. Do you guys, and for the second part of the question, do you guys agree with the number 19? I know this is kind of just direct counting, but if I search for the piece TV in the sentence, would it return back 19? Do you guys agree with that? Okay, you guys seem to agree. At least two people agreed. I'm gonna just count this. I don't know the exact answer. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yep, that's perfect. Keep in mind when I counted it, I included the space in the between, and we just look at where it starts. So we wouldn't return 20. That would be where like the substring ends. We don't return that. We return 19 because that's when that substring or that piece starts. There's also a super useful function that I've used before, which is replace all. And this basically just takes the segment is and then replaces it with this replacement text. So here, like we can use this to like, for example, convert this sentence to past tense because we replace all the is into what the replacement substring was. And so instead of Kevin is watching TV shows and he is relaxing, it replaces it with the is with the was and gives us Kevin was watching TV shows and he was relaxing. And I'll give you guys another problem kind of. You guys seem to be getting the hang of it, but I'll give you guys one more. So you see this replace all text. So instead of replacing this, or instead of the replacement or segment is, what if I ask for the segment ing and the replacement is, and the sentence, the answer to this will not be like a sentence that makes any sense, but just to see if you get the hang of it, it replaces it with yes. So what would be the resulting sentence from this? If I use the replace all function, the segment is ing and the replacement is es, and I put that in the chat. So you already got one answer. Let's see, just wait for a few more. Do you guys agree with Sophia's answer? All right, so I mean, two people answered and they both seem to have given the same answer, and I would agree with that answer. The segment ing, we see that in two places. We see that in watching and relaxing, and we replace that with es. So obviously the resulting sentence makes no sense, but it is Kevin is watches TV shows. He is relaxes. Not the best grammatical sentence, but MIT App Inventor just looks for those segments and then replaces them. And it replaces all instances, right? In some programming languages, like it only replaces the first instance, like in Python, if you do like replace, it only replaces like the first instance. But in MIT App Inventor, it just replaces all of them for you. So that's really neat. So great, you guys have gotten all of those questions correct. So let's keep going on to the next part. So now there's Boolean expressions. So Boolean expressions, like we talked about, these are essentially like, I would equate them to kind of like math problems, but they're with Booleans. And again, Booleans is a binary data type that it's either true or false. And you can use these three big operators, and these are really the core ones that you'll need for your code. There's also like exclusive or and other like Boolean expressions, but you're not going to be using them for MIT App Inventor. And basically, it just negates either true or false. There's and, which it essentially finds if both inputs are true and outputs false otherwise. And then there's or, which evaluates the true if at least one of the inputs is true in the problem, right? And so, oh, sorry, I missed a question earlier. If you piece. So Catherine asked if you type watching into the piece, will it result in a true statement or is it case sensitive? I think I can't say for 100%, but I'm 90% sure that it is case sensitive. So it would result false if you put watching into the piece. We can test this out later, but yeah, it shouldn't. All right. So yeah, so back to Boolean expressions. So the use for behind these is for control flow. So like, for example, why would you use and in your programming? It's because if you have two conditions, you can check if both of those are true using the and function. If it's something that you want your program to execute something, if either of those conditions are true, then you can use the or function. So now I'm going to give you guys like sample like Boolean expression. And I'm just giving you guys some examples just so that you get the hang of it. So I'm going to give you two variables. A is equal to true, B is equal to false. And I'm just going to type out a sample expression with A and B. So what would this output if we tried this? So the parentheses means you do them first, so remember that. What would that expression output with those inputs where A is equal to true, B is equal to false? And the expression is in the chat. So you already got some answers. Oh, this one is a little bit, it might take a little bit more thinking, so I'll give you guys a little bit more time. And we have some contradicting answers, so that's interesting. So one person has said true, one person has said false. I'll give you guys, maybe we can get like a tiebreaker opinion. So just give you guys some time. And then after the recap, we'll get into our next walkthrough, our first walkthrough of today. Okay, so we've gotten a lot of opinions on this. I guess two people said false and one person said true. But basically what I'll do is this. So I'll repost the problem. So it's A and B. And I said A is true and B is false. So let's do it like this. So this is, I'll type it out with actual words. So it's true and false, or false and false, right? So let's do what's inside the first expression. If it's true and false, that will output false, right? So what's inside the first parentheses, like parenthetical expression, is false. So that would be false, or, and then the second expression is false and false. The second expression is, that would output false as well. So it'd be false or false, and false or false outputs false. So the answer to this question is false. And then I'll give you guys one more expression. Just this one will be a little bit trickier, but again, just systematically go through them, do what's in the parentheses first, and you guys will get the answer. All right, here you go. A is true and B is false again. The exclamation mark is the same as not, as the not function. So I'll give you guys some time to go through that expression. And again, A is equal to true and B is equal to false. Okay, very quick answer already. Okay, two very quick answers. I'll give you guys some time. This one. Okay, we got three trues, and true is the correct answer. And actually, I think I know why you guys got it really fast. And I'll offer, like, if one of you guys wants to unmute and explain it, feel free to do it. Or I can just do it. It's fine. Because you guys got in very fast, and I think I know why, but go ahead and unmute if you would like to. Just explain. Or you can type it in the chats if you don't want to unmute. Yep. yeah, so that's why it's really easy to do this. For or, remember, or is like if one of them is true, then the output is true. It doesn't matter what the other expression is. So basically, like if you look at this expression, I put it again in the chat. The stuff after the or, like that second parenthetical expression, it doesn't even matter because the first parenthetical expression is true. So because A is true, and then the opposite, and then true and not B, which not B is false. So it would be basically equivalent to true and true for the first parenthetical expression, which means the answer is true. So in other words, the first parenthetical expression is equal to this, and true and not false is basically the same thing as true and true, which outputs true. And so the first parenthetical expression is true, which means that, and since this is the middle thing is like a or, it doesn't even matter. So the output is true. So that's how you guys are able to get it really fast. And just keep that in mind when you're working through your code. And this is an important, like kind of backbone computer science topic that is really useful, you know. So that's great. You guys seem to get the hang of Boolean expressions. So let's move on in the recap. Okay, so actually that was the last slide of the recap. And before that, someone asked, can you put strings in the or? You can't you can't you can't put like true, like a string or a string. You can't do that. But there's different ways to like check, like you could put like a string is equal to a string. That would output a Boolean, and you could put that into the or statement. The or fundamentally it compares Booleans, right? And so you can't put a string directly into the or statement, but you could put a calculation that outputs a Boolean into the or statement. So for example, you could put, instead of true or, like if you want, you couldn't do something like this into a Boolean expression, like cool or not cool, but you could do something like a bigger expression like this. This will take some time to type out. You could put something like this into a Boolean expression. It would give you a valid result, right? Because the first parenthetical expression would output a Boolean. The second parenthetical expression would output a Boolean. And with that, you're able to use strings and put it in the or thing, but not directly, if that makes sense. All right. So what I'll do right now is, and if there's any other questions, please feel free to put it into the chat right now. But what I'm going to do now is we're going to get started with our first, or kind of walkthrough project of at least the lessons that I've taught. So go ahead and open MIT App Inventor, get your App Inventor companion set up. Go ahead and I'll give you guys like a few minutes to get those stuff ready, and I'll go ahead and share my App Inventor page. 1 second. So go ahead and get your App Inventor companion. If you're using the emulator, get all of that stuff set up. Go to MIT App Inventor, log in, do all of that stuff. I'll give you guys like a minute or so to do that. I'll give you guys like maybe like 1 more minute or so. Let me know if you're having any difficulties. Just like you can DM or on like Ambrose, the TA, or me, or Dr. Meng, if you're having any problems with the setup. I know the emulator is really weird. Like honestly, like it just like it requires a little bit more setup. So Dr. Meng also suggested that I recommend to all of you guys to get an Android device for the hackathon. And just to be using, it's best to use MIT App Inventor with the AI companion on the Google Play Store on an Android device. Emulator is fine, but also keep in mind that the emulator doesn't have some functionalities, like you can't use like sensors on the emulator. You can't do things like that. So I would suggest using an actual device. Plus, it's just cooler to use the actual device. So let us know. You can obviously message us in the chat if you're having some setup difficulties. I know some of you have iOS devices, but yeah. And Catherine also says like Dr. Meng has given like some Android devices. There's like a cheap alternative that you can easily buy. It's well worth it, I would say, especially if you're really interested in computer science, like app development. I would say it's always great to have an Android device just to work with. And for App Inventor, it's almost like a necessity to have an Android device. So check out that Amazon link. But anyways, I'm going to go ahead and share my screen. I think, again, like if you have any difficulties in the setup, just let us know. But yeah, so I'm going to go ahead and share my screen. And so this is MIT App Inventor, this page. You should be getting something like this. And so what we want to go ahead and do right now is we want to start a new project. We're going to call this project Talking App. You can call it whatever you want. I'm just calling it Talking App. And once you do that, and again, yeah, click the Start New Project button to do this, you get the screen like this. And let me go ahead and separate it like that. So let's just recap real quick. Obviously, all this stuff should be familiar. Right now, we're in designer mode. We have the palettes right here. So we have different user interface elements, and we're going to be using some of them today. Layout things, experimental things, sensors, maps, which we'll be using in a later lesson, all this sort of stuff. We also can tinker around with the viewer, which shows us how the app was actually going to look like on our device. You can mess around with what sizes you want, tablet size, monitor size, or just phone size. Your components page, which shows us the different elements that we have on our screen. Non-visual components, like stuff that you don't see on the screen, like sensors and stuff, will be shown right here below everything. And then we have our properties page where we can mess around with different elements of not only our screens, but our functional elements from our palette. So for example, here, like the screen, I could change the color, the background color, by just messing around with this color. And you see that property changes right here. After this, we have, and also we can add screens because more complicated apps, there's going to be multiple screens just by definition, really. So right away, let's go into the blocks component. And then we also see the built-in commands that we've been talking about a lot, like control elements, like if-then statements, which we covered pretty extensively yesterday. Logic, which is like our Boolean values, math stuff, so our numeric values. There's also like sine, cosine, tangent, arctangent functions. Binary, you can convert from like different bases. I don't know like what exactly you would use that for, just in like a non-math app, but it's there for you. And our text functions, which we're also going to be using a lot today. There's also lists and dictionaries, and lists and dictionaries are something that we will get into later on after one of our walkthroughs. Then there's also colors, which are just color values. These are kind of another variable type in MIT App Inventor outside of kind of the big three. So you see all the different colors here, and you also can make your custom color using like RGB code, as well as variables and then procedures that you can use. And all of these are built-in commands. And then also when you drag in your own elements, you also will see extra components and extra component specific commands for programming. So today, the app that we're going to make in our first walkthrough is basically just going to be like a talking app. So what we're going to do is we're going to, let's go ahead and you can set the background color to whatever you would like. And what we're going to do is make an app that we can type text in. And then when we type a text in, when we click a button, the app will say that text to us, which is pretty cool. So what we're going to do for that is we're going to start off by taking text. So we're going to take a text box. And one more thing before I get started is like this arrow right here. If you hover your control, you click on that little question mark thing next to the component, you can read like a little write-up about what this is, specifics about it. Like if you're not sure what an element even is in the palette, that will be in handy, especially if you're just getting started. So let's put our text box right here. I'm going to go ahead and type out like a hint. And a hint is basically like, it's hard to kind of verbalize what a hint is, but like basically it's not like your text, but it's kind of what shows up before the user actually types in within this text box. So I'm going to say like in the hint, like type text here. Type text here, put exclamation mark. And I'm going to also like align my text. I'm going to center my text just because it looks nicer. Height, we can just keep our text like kind of right here. You can mess around with different kind of components of the button. You can change the button background color. I'll change it to like a gray color. I think that looks nice. Actually, it doesn't look that good, but change it to like, I'll just change it to a white color. That's fine. And this is where our user can input text for our app. And then very importantly, we need to add a button. So we go ahead and drag our button right here. And then our button, let's just make this like a green color. And then our button text, let's type in say this text. And so it automatically updates here. The hint, it won't show automatically on the viewer. I don't know why they do it like that. If you worked with Android Studio, it shows the hint, but for MIT App Inventor, for some reason it doesn't. So anyways, we have our button right here. And basically that's all our design elements for this simple version of this walkthrough, right? And you can go ahead and mess around with different features, of course, if you choose to. Next, let's go into our blocks elements. And here we see right away that we have our different elements right here under screen 1 of our app. And for our app, it's not going to say things itself without one really important element. And that actually is our last element that isn't a visible element on our screen, which is the text to speech. Text to speech. And so search on the palette for text to speech, and you'll see that right here. And I'll go ahead and drag the text to speech onto the screen, and it'll show up in the non-visible components. I'll give you guys a little bit of time, like maybe a minute or so to catch up. I know I hope I'm not going too fast. So just go ahead and like your screen should look something like this. Obviously the colors and stuff, that's kind of miscellaneous stuff, so don't worry too much about that. But most importantly, this text to speech needs to be here. And then you need a text box as well as a button. And actually just realize like the hint shows up right here if you hover your cursor over it. So that's where it is. So I'm going to go ahead and monitor the chat. Just let me know if you're ready. You can just put like I'm ready or ready into the chat once your design elements are where you would like them to be. I'm not going to do a horizontal arrangement now. That's just like if you want your stuff to be like centered on the screen. For now, it's fine. You don't need to do that, but yeah. And also like one other cool property of the button is if you want it to be multi-line. So like if you want to be able to go like type a lot in your text box, you can just check this. And you could also do like numbers only or read only if you don't want it to be interactive. But in this case, we don't want that to be the case. So let's just do a multi-line if you'd like. It should be set up like this. Only 2 people have said they're ready, so I'm kind of assuming that people aren't ready. So I'll give you guys like maybe 1 or 2 more minutes just to get the design part set up. Okay, I'm gonna move on at like like in another minute. So let's go ahead and mess around. I guess if you're already done, kind of just mess around with the design how you'd like, make it look how you would choose to. All right, I'm gonna go ahead and just move on. Obviously, if you're struggling or something's not going well, just feel free to message either Ambrose or me or Dr. Meng, and we can help you like get any sort of technical problems fixed. But let's go ahead and move into the blocks. And so you click on the top right to move into the blocks. And so let's think just like big picture about what we want to do. We want the user to click on our button, or first actually we want the user to be able to type in that box. Then when they click on the button, our program or our app should say that text. To do that, we need to use an event handler for the button, because really all the magic happens when the button is clicked. So we click on the button, then we look at the different events. There's so many different events right here, but the main one that we want to use is one button one dot click do something. So this is an event handler. So we move this right here. So when button one is clicked, we want to do something. And what we want to do is we want it to say our text. We want our text to be said, whatever the user typed. And to do that, we need to click on text to speech. And then we need to do call.text to speech one, this component, and we want it to speak a certain message. Now, what message do we want it to say? We want it to say the message that the user inputted, right? So we go to text box one, and this is text box one is where the user's input is, and we can say text box one, and then what property we want? We want text, so we want it to say text box one text, like this. And so basically, this is our code. And I'll give you guys some time to set that up. I know I went pretty quickly, and I'll re-explain this just so you get the logic of what's going on behind this. So yeah, give you guys some time to get that settled. All right, let me go ahead and explain this text or this code. So basically, again, we use an event handler when the button is clicked. Then we call the text-to-speech.one tool that we have in our design, and that's a non-visible component that we have right here. And then we ask it to give us the text that is in text box 1. So now go ahead and click connect if you want to run this. This code should be ready. And you can click on AI Companion, App Inventor Companion. Don't use this code right here. Again, this is just specific to me. You'll get your own code. So let's go ahead and try that. And I'm going to open my MIT App Inventor 2 companion app. I type in that 6-digit code, or you can use the built-in QR code scanner. I think it timed out. Okay, I don't know what's going on. My phone is kind of lagging, but okay, nice. My internet is a little shaky on my phone, so let me try. Let me know if it's the code is working. I think it is working for you guys. It should work, but trying to get it to work on my phone. Right. So can you guys like say in the chat whether the app is working? Like, actually, I'm not able to run it on my phone. Sounds like it worked for Russell. Okay, it's working. Nice. That's cool. So you guys have built a working text-to-speech app, which is pretty cool. And if you think about it, this is kind of the bare bones of like what you could do with this. There's a lot more that we can do. And we're going to do some more walkthroughs and more kind of user input type stuff with this app and with this walkthrough. But we'll do that after a short break. So what we'll do is we will come back around like we'll just come back at around like 103, 104, something like that. Actually, we'll just make it around time. So like 105, something like that. Come back and we're going to pick up where we left off and keep exploring MIT App Inventor and learn some new things. So thank you guys. All right, guys. Let's go ahead and get started again. We're gonna get started basically with the loops part of our lecture, where we're going to talk about things like for loops, while loops, all really fundamental things in programming. And let me go ahead and share my slides. Okay, so here go. Okay, so now let's talk about loops. And what when we think about loops, basically a loop does a task multiple times by iterating, and iterating is like a really common word in programming, and you're going to probably hear that word a lot more today and later on, or repeating in different ways. And so for a for loop, basically a for loop, what we can think of a for loop as is like we want to do something a set amount of times. Let's say I wanted you to pick up a pencil like 30 times. I wanted you to pick up the pencil, put it down 30 times. Then that would be something that maybe like a for loop could apply to, where we have, and as you can see here in this this block right here, we have a for loop that goes from a number from a starting value to an ending value, and then by a specific increment. So for example, here we in this for loop, basically we want to do something. Obviously this wouldn't really do anything, like just a string of text saying does something, but like for example, we could like print out a statement, or we could make the text to speech do something or something like that in that for loop for each of these times or each of these values. So if we're thinking about this conceptually, what this for loop is doing is it's iterating through every number within this range. So it starts off with the number 1, does something, then it increments that number by 1. So then it goes to the number 2, it does something, then it increments again to 3, does something, increments again to 4, does something, increments to 5, and that's the ending value. So do something for one last time, and then it'll exit the loop. So now I want you to think about how many times would this statement does something, or how many times would this program do something if the increment was 2. So let's say we started from 1 to 10 by 2. How many times would this loop do something? That's a problem for you guys. And it's in the chat too. So this is a for loop for each number from 1 to 5 or to 10 by 2. How many times would the part in the do, which is like does something, how many times would that thing get called or yeah. So you have some different answers here, which is interesting, or different ideas or interpretations rather. I'll wait for like one more maybe. Yeah, so the answer is 5. So the 1 does count, like the starting value does count. It would be 1, 3, 5, 7, and 9. So so it'd go through all of those different values. I know in Python it doesn't go to the last value. It doesn't actually execute the last value. So I may have said that wrong earlier on. I'm not sure in MIT App Inventor. We'll check that out later on. But it definitely does do the first value. It definitely does execute the starting value. I'm not sure if the ending value is included or excluded, but yeah, so it doesn't really matter in this problem because it never will hit the number 10. So it would be 1, 3, 5, 7, and 9, right? So that's how you do a for loop. As you can see, it's a fixed range, and just looking at the for loop right away, we can easily see or calculate how many times the loop will execute, or whatever the stuff inside the loop will execute. The other types of loops, the very common one is called while, or actually no. Before we go into while loops, we have for loop variations. And so for for loop variations, sometimes you can, for loops again are mainly used for doing a repeated task a specific number of times. But sometimes instead of like looking through each term or a list or just through a set of numbers, we can actually iterate through a set list or set dictionary. So a list, for example, let's say we have the list of terms, a list of strings like, how about this? I'll type in a list of strings into the chat. So we have a list like that, A, B, C. So either one thing that we could do is iterate through the different terms of the list directly. So instead of going like counting from numbers, we can also just check for each key in this dictionary so we can check A, B, and C for the length of the dictionary. And that might not be easy to wrap your head around right now, but we'll definitely go into the specifics later on. But I guess big picture, what you want to think of is like, yeah, so a dictionary is a set of terms. It's basically like a collection of terms with a value. So it's like a correlation between a key and a value. Actually, what I typed out here, the A, B, and C, that's a list. But a dictionary would be something like with a key or a value. So for example, I could set up a Roman numeral dictionary, like something like this. I'll type it out again. And it looks different in MIT App Inventor, but this is just to give you the idea of things. Yeah, Ambrose also typed it out. This is another way to think about it, like something like this, where we have like a key, which is like, in this case, the key would be like the Roman numeral itself, and then a value that correlates to that key. Again, this is just to give you an idea of how for loops can work. We'll get into like what a dictionary is and like a list is later on, but this is just to show you the different variations of for loops that you can see. So this is an example of for loop. We already showed you one example, but here's another example. Here we want to try to find the sum of the numbers from 0 to 5. And as you can see here, this for loop essentially goes through each number from 1 through 5. And it looks like it does include the last number, so that's interesting. So I guess my guess was correct. In MIT App Inventor, it does also execute the final number. And what you can see here is we have initialized a variable called sum. We set that to 0, and then each time we iterate through this loop, we add a number. We add this number right here from the loop into sum. So let's map this out. We start off with sum is 0, number is equal to 1, then we go into the loop and we get the original sum, which is 0, then we add our number, which in this case is 1, to the sum. So right now the sum is equal to 1. Then we go back to the loop. Originally we started off with 1, now we have to go up by 1, so now our number is equal to 2. We go into the do part of this for loop, and we get the sum, which in this case was 1, and then we add the number 2. So the sum is now equal to 3. Now we increment again, number is equal to 3. The previous sum was equal to 3, and we're storing that sum in a variable, and we keep going on and on and on until we add up 5, 4, 3, 2, and 1 via the variable number. And so that's how we get the final answer, 15. Let's say, what would we get if we incremented by, I'll ask you guys, what would we get if we incremented by 2 instead of 1 in this loop? Go ahead and just return what answer you think would result if we incremented by 2 instead of 1. Yeah. You guys can just put like the final sum into the answer, into the chat. Like, what do you think the final sum would be? Like at the end, what would sum equal to? One thing to remember is that it would execute, at least looking at this example, it would execute 5 as well, right? Because 1, 3, and 5. So it would also go to the last value. Yeah. Right, so yeah, the answer is 9. So it would go 1, increment by 2. So then it would go to 3, increment by 2 again, then go to 5. And so the answer to that, the sum of that together would be 9. So 1, 3, and 5, the sum of that together is 9. So remember, I know like sometimes in some programming languages, they don't include the last number in the for loop, but I guess in MIT App Inventor, they do. So that's just some convention that you should remember while you're programming. All right, so that's for loops. Let's keep going. All right, so now we get into something interesting, which is while loops. And while loops, they work differently because they do it a specific number of a repeated task a specific number of times, but that not or do a task a number of times, but that number is not known. So it repeats tasks based on a conditional. I told you guys about like I asked you to pick up your pencil 30 times. What if I told you I asked you to pick up your pencil 30 times until I walked out of the room? Or not pick up your pencil 30 times. I asked you to keep picking up your pencil until I walk out of the room, right? And so you don't know when I'm going to walk out of the room necessarily. So you're going to pick up your pencil an indefinite number of times until a conditional, in this case, whether I'm in the room or not, changes. And so this is how a while loop looks like in MIT App Inventor. And essentially what you're trying to do is you're iterating through until this condition evaluates to true. So this initial variable is 15, and this while loop would keep going through this loop as long as the global variable x is greater than 0. And let's elaborate on that a little bit more. So this is an example. This might be a little bit hard to understand, but don't worry, we'll go through this all. An example of a while loop. So in this problem, basically, these first two blocks are basically just picking up a random number. It's just initializing a random number from 1 to 6. It's using the random number generator. So in this example run, let's just imagine that A is equal to 3 and B is equal to 4. Now this while loop, which is inside, is where the real like kind of magic happens. Basically, the conditional in this case is whether A plus B is equal to or not equal to 12. As long as A plus B is not equal to 12, this while loop will keep on running. So in this case, 3 plus 4 is equal to 7. That's not equal to 12. So let's go and do what's inside the while loop. Inside the while loop, you see that A and B are reset. A and B are resetting. Let's imagine that now they're reset to 4 and 6. 4 plus 6 is not equal to 12, so the loop continues. Now let's imagine that the loop keeps on going until finally we get a little lucky and A is equal to 6 and B is equal to 6. Then A plus B is equal to 12 and we stop. We don't do what's inside the loop once this condition is met. Now, there's something interesting to think about here and something that a mistake that could arise in while loops that won't necessarily happen in for loops that you have to be very careful of. Sometimes these loops can go on indefinitely. Let's imagine for whatever reason, I gave you that pencil analogy, so let's just continue sticking with it. You keep picking up your pencils. I tell you to keep picking it up until I don't leave the room or until I leave the room. But what if I just stay in the room forever? Like I would not do that, but like if that means that you're going to continue picking up the pencil like indefinitely. In this case, for example, just in this while loop, what if I said A plus B is not equal to 13? This while loop would keep on going forever because you would never mathematically, it's not possible to get something that makes that while loop condition true. So that's something that you have to really keep in mind when you're using while loops. And yeah. And Dr. Meng gave a practical case like rolling 2 dice. This is basically like a simulation of rolling 2 dice if you really think about it. And we keep going until the sum is 12. So there's different examples. And again, this loop keeps on executing until that conditional is true. All right, let's keep going. All right, so in this case, this loop basically initializes a local variable. It's called num to 21. And the while loop condition is that num, whatever num is, it can't equal 0. Once it's equal to 0, the loop stops. And so once we're inside the loop, we set the num to the original num minus 4. So basically, we're just subtracting 4 from the variable num. So if you look right here on the side, let's just map through what's going on. We start off with 21. We check the while loop, not met. It's not equal. 21 is not equal to 0. So then we set num to 21 minus 4, which is 17. Then we go back to the loop. 17 is not equal to 0, so we keep on going. Then we do 17 minus 4 is 13. Then we keep subtracting on and on and on and on and on. And you see the problem that arises. It's a similar problem that I talked about with like the pencil analogy. We're getting into an infinite loop because mathematically, if 21, if we keep subtracting 21 from 4, 21 is not equivalent to 0 mod 4. So by continuously subtracting 4, we're never going to equal 0. So this loop will never stop. It will keep on going forever and ever. And you're going to see an error come up when you try to compile this or try to run this on MIT App Inventor. Something weird will happen because your code will never stop. Your code will never exit this loop, which is not what you want. So that's something that you want to keep in mind. And so now I would ask an interesting question to you guys, and this is kind of more of a math question, but it's something that you can think about when you're looking at the while loop. How many times would this loop run if I initialize num to 24? How many times would this loop run? And already a very quick answer. All right, we got one answer. Anyone else want to agree or disagree with Russell's answer? All right. I think people might be still looking through it. Yeah, it's okay to guess. You can also yeah. I mean, these while loops they're kind of tricky. But just go through them. Oh, I'm sorry. Again, it's 24 and we keep subtracting 4. And a great way to do it is just to write out your answers right here, like on this, like how we did right here. Literally just map through it and see if you can also find patterns. Maybe you can try smaller. Yeah, I guess we're technically not dividing by 4, but I guess we're subtracting by 4, which is in essence I guess the number of times it goes, it's essentially like dividing by 4. Yeah. All right, I'm going to go ahead and just start explaining it so that we can cover some more stuff. But basically, I do believe the answer is 6 if I did it correctly. Because you're starting off with 24, You check that original condition, so that's 1. Just hold up my, then you go subtract it, that's 20. So you run it once for, you run this once for 24, you run this again for 20, then 16, then 12, then 8, then 4, and then you don't run it again. So you only run it 6 times. And in essence, that's essentially dividing by 4. So the number of times we'll run it is essentially num divided by 4, unless it's 0, then, or yeah, even if it's 0 actually. So that's one way of thinking about it. All right, let's keep going. All right, so sometimes you want to use a break statement, and this can be used to get out of a loop. So sometimes you want to be checking something like if you increment, as you increment, is something equal to another number. So in this case, for example, we're trying to iterate through 1 through 5 incrementally, but once we get to 3, we don't want to keep checking. We don't want to check, once we found 3, we don't want to check 4 and 5. We already found 3. So in that case, you want to break out of a loop. And to do that, you can use the break statement. And so this essentially forces it out of the loop mid-iteration when a conditional is evaluated to true. And sometimes, like, especially if you're checking really big sets of numbers, this can save you a lot of time and decrease the average time of your program. And so this is something that's very useful to use in MIT App Inventor as well. Next, let's take a look at nested loops. We talked about nested if statements, but there's also nested for loops. And so these actually act as like rows of iteration. So essentially what this does is it's iterating from 1 through 5 at the top. Then it iterates for another number from 1 through 5 inside that loop. And so sometimes, like, for example, if we, this code for right here would run 25 times. And so sometimes you can use this as you need. There's not a lot of applications necessarily outside of like kind of math or searches, but you can kind of simulate also like a larger array too, if you do something like this. All right, so let's keep going. All right, so here's some more uses for nested loops. And so this can be used to iterate through tabular data. So for example, you could have one nested loop on the outside iterating through rows, and then another nested loop on the inside, another iterating through columns, matrices, two-dimensional arrays. I've also seen some bigger problems, programming problems, where they have even three-dimensional for loops. It's kind of inefficient, but you can check through rows, columns, and then another dimension too. So loop through two similar lists with different uses, that's when you'd want to use a nested for loop. There's also loops and conditionals. We showed an example earlier with the break function, but essentially with loops and conditionals, you can go through a lot of different terms while you can use this kind of to search through something. So you can iterate through all the items in a list and then try to check if something meets a condition. So for example, like let's say we wanted to check through the numbers like 1 to 10. If we wanted to check if numbers are greater than 5 or not, and then have a counter in between, there's different ideas that you can use a loop in combination with a conditional. And if you use an if statement, oftentimes, if you're checking for something specific, you can also use a break along with a loop and a conditional. And we'll get into some more specific examples of this later on. This is just to get the idea of kind of what loops and combinations of conditionals can be used to do at a larger scale. I'm going to keep going. So now we have loops and conditionals, a more specific example. So in this example, what we want to do is we want to have basically, we want to repeat 100 times to check if a random integer variable is equal to 50. And if it's equal to 50, let's break. So essentially what we want to do here, or what's going on here, is we define a global variable I, which is equal to 1. And this checks while 1 is equal to less than 100. And so essentially, and then what you see at the end here from this initial condition is we set I to I plus 1. So every time after we go 1, we check when I is equal to 1. Then after we do all this stuff in the middle, then we increment it and then check I is equal to 2. And we keep going on and on and on until finally I will equal 101, and then that doesn't meet this initial condition. And so it exits out of that while loop. So that essentially gets this first part done, repeating 100 times in our loop. You could very easily also use a for loop here, like a for loop from 1 to 100 incrementing y1. But for whatever reason, we chose to use a while loop right here. Next, there's also the second part, which is kind of this inner part of the code, which is trying to meet this random integer variable is equal to 50, and if so, break part of our kind of objective. And here what we do is we initialize a variable x is equal to 0. In this line right here, the second line kind of our code, we randomize it to a random integer from 1 to 100. And then we do this check. We check if that random integer is equal to 50. If not, or if it is, then let's break. We found it, we met our goal. If not, however, then we want to leave, or then we want to check again and do another iteration of this loop. And so basically what we're doing again is we're repeating 100 times through the variable I, and then through the variable x, we're generating a random integer and then checking, and if so, we break out of the loop. So feel free, I know sometimes looking through this might be a little, it looks like a lot, but actually if you dissect it and look at what you're trying to do and correlate it to your objective, correlate the code to your objective, it'll make a lot of sense. And feel free to put any questions about this into the chats. We'll be happy to answer it. Okay, so Dr. Meng asks, is the while loop logic equivalent to a for loop from 1 to 100? Logically, while loops, it's meant to go through a condition. So like it stops at a specific condition. A for loop logic, it has a number of times and it will go through that unless you add a break statement. In this case, the while loop, I don't see why it's functioning differently than a for loop, logically speaking, because all the while loop is doing is just checking until as I increases. So it's basically like, this is just like an increment, and it's functioning very similar logically to a for loop. But as we can see, like with like I talked about the pencil analogy, like picking up a pencil, logically a while loop can go on indefinitely until a condition is met, while a for loop goes through a set amount of iterations. But in this problem, a for loop could easily be used to substitute this while loop. All right. All right, so now we're going to go back to MIT App Inventor, and then we're going to do something a little bit more interesting. We're not going to do exactly a passage search, but it's going to be something similar where we're going to combine a lot of the different things that we talked about. So go ahead and go back and set up your MIT App Inventor companion and MIT App Inventor, and I'll go ahead and get mine set up real quick. All right, let me go ahead and share my screen. All right, so we're back to the button code in MIT App Inventor. And so basically what we want to do here is we want to implement a passage search. So let's think big picture. What we're trying to do is we're going to type in some text, and then we're going to ask the user to type in like a substring or a small code. And what we want to do is search whether that substring is in the larger text. If it is, we want to say, some text-to-speech output. And so this is very simple. What we're going to do from here is we're going to add, first we're going to add a smaller text box. So let me go ahead and do that. This text box we're going to add right here. And I'm going to rename my components just so that it's easier to understand. So I'm going to click on that component and I'm going to type this larger text. And I'm going to rename this to key or input text, or a better name. I'll call it like key text. This is like the key text that we want to search for. Then button, I'm not going to rename any of these because I don't have more than one. So I have the larger text, which is like the larger input, the larger multi-line string that the user can put in, and then key text, which is a smaller text. So go ahead and get that. I'll give you guys like a few seconds to get that set up right there. And again, all I did was I dragged a text box onto the screen and put it below. All right, now let's keep going and looking at the key text. So for key text, first of all, I want to make this a different color than larger text. So I'm going to set larger text to like this like gray color. And I'm going to set key text to actually I'll check larger text to like a light gray color. And key text, I'm going to set this to like a pink. Oh wait, never mind. That's the background color. Orange sounds about right to me. And as you see, the larger text, I let this be multi-line, but for key text, I'm not. And for the hint, I'm going to type in text to, or I'm just going to type key to search for. And then I'm going to rename larger text to larger text to search. So larger text, I've renamed to larger text to search. I've enabled multi-line. I'll let this sit for a few seconds so that you guys can get this on your screen. And key text. I set to key text, key to search for. So I'm going to search for this key within the larger passage. And someone has messaged. What's the hint for key text? It's key to search for. I think the font might be a little small on mine, so it's that. You guys can set it to whatever you want. It's like that doesn't matter too much. Feel free to get creative with it. And I'll leave that for a little bit. If anyone is wondering like about specific details of like how my developer screen is set up, just put it in the chat. I'm gonna wait for like a minute or so because I think some people are catching up. All right, now let's go to the blocks page. Blocks again, back here. And so I'm gonna go ahead and like, just like, oh wait, actually one last thing, sorry about that. For designer, in the designer, let's change the button into, instead of button 1, say this text, let's rename that to check for key. Because our program is a little bit different right now. So it's check for key right now. All right, let's go to blocks. So in blocks, I'm gonna go ahead and just remove this trash, our previous code, sadly. And so big picture again, and yeah, you can save them. I can save the empty screen. Big picture, what we want to do is we want to check if our key is within the larger text. So to do that, all of this happens once we click the button. So we're going to go back, click on button 1, and get the event handler for button 1. So when button 1 click, and again, if you need to catch up, obviously all the code will be here. So just try to keep up and let me know if you have any questions, of course, once again. But when button 1 is clicked, what do we want to do? We want to do our check. And so our check, if you think about it, has two different possibilities. There's either, yes, our key is within our larger text, or no, our key is not in our larger text. And that, when I say there's two possibilities, right away you should be thinking about an if-else statement. So I'm going to go ahead and put out an if-else statement within our code. And essentially, we're going to be getting our text from the larger text and key text and checking whether it is in that. So for that, we can use the contains, right, like that. And we want to see if the piece from our key text is within our larger text. And to do that, for key text, you go to key text, text. Oh wait, whoops. Actually, I'll go get larger text.text. And then key text.text. So we're going to get the text from key text and check if it's in the larger text. I'll give you guys some time to catch up. Just give you guys like a minute or so. And in the meantime, I'll explain like basically what we're using the contains function that we explained earlier. It's coming to perfect use right now. And we're just checking if our key text is within our larger text. And that's the conditional. This contains will remember it gives us back a true or false, which is why it fits in perfectly with our if-else statement. So if that's true, we want to do something. If it's not true, we want to do something else. All right, I'm going to keep going. I'm going to go ahead and go to text to speech. And what we want our text to speech to say is we want our text to speech to call text to speech. And we want it to say two different things. We don't want it to say the same thing if the text isn't found, right? And so we put that in twice. This then right here is if the if statement is true. This else right here is if the if statement is false. And we want it to say a specific message. So we can go to text and then drag out two of these texts. All right. I'll give you guys some time to catch up with it. And of course, again, feel free to use the chat. All right, we're going to do a simpler version, but then we'll do a little bit more complicated, which will use another string functionality. But if it finds it, it'll say, yay. Oh, you don't need to do a quotation mark. Yay. I found the key. If it's not true, then it says, oops, I didn't find it. And so this is our backbone of the code. I'll just leave this up here. And once you get this working, why don't you guys go ahead and go into Connect and then try running this code and put in the chat if it works for you guys. And if you guys want me to show anything in the designer mode, just let me know. I can easily switch there. Does it work for you guys? Cool. Nice. And so now I'll give you guys another challenge that we'll think about. How would I do this if I wanted, if it is there, I wanted to return the key, the first index that I find the key in the larger text. What function could I use, or how would you recommend going about it? I'll give this out to you guys, and then I'll go ahead and implement it here. And I'll show you some of the text functions because I'll give you a hint, it requires a text function. Oops. Okay, I think this actually might be harder than it, like to type than, but basically we can use this command right here, starts at, and we have to use kind of a special kind of string format. So basically we have to do like a join, right, like this. And we have to say, yay, I found the key at index. Then we add a space right here. And there's a space right there at the end. So, and then we want to say the index that it's at. So yay, I found the index at index. And then this starts at function, which was the key here. This one is the magic function that will give you back where the index of where the key is in the larger text. Yay, found the index at, and then to get the actual index, we use starts at, so we want to join it right there. And again, to make it readable, I added a space at the end because remember, when they come, the join does not add a space automatically in between. So I have to go and add one myself. And so now we go get our larger text. Text. All right. So this is how the code should look like. Let me see if I can zoom in a bit more. Okay. This should be way easier to read. Let me know if you don't understand this part. Basically, again, I'm just returning back the index to get this all working. And then go ahead and try doing this and see if it works for you guys. Yeah. For that, Russell, you would need a loop, just like Ambrose said. You would have to go through four. Let me see how you would do that. Ignore what I'm doing below this block. I'm just yeah. So you would turn the string or your string into a list, and then you would say for each item or for each number in list, and then you would print out each item. So that's how you would do it. You would just cycle through each character in that string. If you guys can let me know also if this code works, if it works as intended, go ahead and just run it once you've gone in this. Of course, feel free to continue asking any questions. And if you're looking for certain blocks, you can obviously look at the color and then you can match it right here. And just look. Yeah, and if you guys could let me know if it works, that would be great. So I made sure I didn't do anything wrong, although it looks perfect. Oh. Okay, seems to work. Sophia, if you could just, double check if your code is exactly like this. Make sure your inputs are clean also, like your inputs are as expected. You can also try just messaging Ambrose, he can help you. All right, guys. I'm gonna leave this up here for now. Okay. That looks like identical to mine, Sophia. So make sure your inputs are good, like your inputs are normal, like you don't have extra space or something like that, like something, yeah. Catherine also brings up a good point. Like sometimes you might have like random pieces like rent around that you didn't trash, and I think that might like be a problem. So just make sure you clean up your space. And either way, you want it to be clean anyway, so that when you're coding and other people look at it, it looks good. So and easy to understand and readable. But I'm gonna go ahead and leave this code up here. It seems to be working for multiple people, so that's really nice. Congratulations for building for some of your first MIT App Inventor apps. You can see all the theory that we've done, and I know it's a lot of theory and background on programming. We can see how it's being put to use and different examples of that. So that's always really cool. There's nothing else I really have planned in terms of this lecture besides those walkthroughs. So just go ahead and if you have any questions, feel free to ask. If you need any help debugging or trying to get your code to work, also let us know. But I'll leave the rest of the time for you guys just to ask questions. But thank you guys. Thank you guys for coming. Yeah, thank you guys so much for coming. And again, I'll be staying on for a little bit just if you need any